Good afternoon, grade 7s. We're going to look at another pattern example question. Question says, study the pattern of rectangles made from toothpicks. Rectangle 1, 2, 3. How many toothpicks would be needed in rectangle 4? So one of the first things that we would suggest you do, and it's going to be your best friend, is making a table of values. Okay. Remember, a table of values is our X and Y chart, or fancy for input, okay? X being the input, Y being the output. In this scenario, we're going to think that the rectangle number is our input, and we're going to think of the output as the perimeter or number of toothpicks. So looking at our example here, we could just say and fill in the table of values. So rectangle 1, how many toothpicks were there? 6. In rectangle 2, we would count and find that there were 8. In rectangle 3, we would count and discover that there were 10 toothpicks needed to create this perimeter. Now we're asked, well, how many would there be in rectangle 4? Now we could look at the pattern. Okay, it seems like it's going up by 2. So we could say that, hey, perhaps if the pattern is increasing by 2 each time, then in rectangle 4, we would need 12 toothpicks. Now, using this information here, we're going to move on to the next part. The next part says, what is an expression for the perimeter of any rectangle in this pattern in relationship to the rectangle number? Let's pull up our chart here, or table of values. So could we create an expression for this pattern? Now, why might we want to create an expression is because, well, what happens if I said, what would rectangle 15? How many toothpicks might there be? Yeah, sure, you could continue this table of values all the way down to 15, but that wouldn't be very much fun. So we're going to come up with an expression that will work for, say, even the 70th triangle. So what we're going to do is, and we saw it in the previous page here, but we're going to look at what the skip count is. Now, each time there was an increasing pattern, in this case, of +2. Let you in on a little secret, this +2 becomes your numerical coefficient. Your numerical coefficient, remember, is that which multiplies the variable. In this case, the variable is our input, or rather, the rectangle number. So we will use that R to represent the rectangle number. That is going to give us the output, and in this case, the number of toothpicks, or the perimeter. So what we're going to do now is to confirm that this expression works. And we're going to do that by trying it out for at least 3 of our inputs. So taking a look here, I would say replace that R, the variable R, with the first rectangle number. 2 times 1 equals 6. Well, that's not right. Well, how did I get from 2 times 1 to 6? Well, I could add 4, right? 2 times 1 is 2, add 4 is 6. So we're going to say, hey, and we're going to put this out there and say that we predict that our expression is 2 times the rectangle number, add 4 equals our output, the number of toothpicks, or perimeter. We tried it out with our first input, rectangle 1. Now we'll try it out for, as I said, for at least 3. So 2 times rectangle number 2, add 4. 2 times 2 is 4, add 4 equals 8. We'll try it again. 2 times rectangle 3. 2 times 3 is 6. Add 4 equals 10. Let's go back to our table of values, and sure enough, those match. 6, 8, 10. So we can safely say now that this expression works. The expression for the perimeter of any rectangle as it relates to the rectangle number is 2r add 4. Again, we did it for 3 attempts or 3 inputs. And as long as they work for 3, we know that this is the safe expression. So now we can take this expression and we're going to try and see if we can calculate any number for a rectangle, or any number rectangle. So the next question is, what would the perimeter for rectangle 10? Show your work. Well, I'm just going to take my, go back and get that expression. Now we're going to use this expression to determine how many toothpicks, or what the perimeter would be for rectangle 10. Let's take my marker here and we'll see. So 2 will stay the same, and we're going to replace that r with rectangle 10. And we'll keep our expression. 2 times 10 is 20. Add 4 is 24. So in rectangle 10, there would be 24 toothpicks. Let's, for example, say it asks, the next question said, well, what happens in rectangle 22? How many toothpicks would be needed? Same thing. Now I could use my expression and virtually do any rectangle number. 2, and we'll replace the r with 22. Add 4. 2 times 22 is 44. Add 4 would be 48 total toothpicks. Please note that if you take a look in all of our examples, the best way to organize your work is by lining up our equal signs, lining up our variables, lining up our constants, lining up our numerical coefficients. Just an easy way to keep track of our thoughts and to keep track of our work so that we might be able to see if we made any mistakes. Go ahead and try some of the examples out in your textbook as well as quizzes.